In this lab, I want to talk about airodump-ng. Now, this lab I generally only run after I run the air monitor setup, which you're going to want to see that in a previous lab. But airodump is a great program to run from the command line to basically set up and start dumping traffic and get a summary of actually what's going on, depending on how you actually want to set it up. So we're going to do an airodump-ng and set it up as a a listener. But first, you got to type it correctly. So it's airodump tac h, and that'll bring you to the help file. And you're going to want to read this information through at least one time, especially if you're not familiar with this. So basically, the command is relatively simple. It's just airodump, any sort of options, or the interface or interfaces simultaneously that you want to monitor. Okay, I generally only run this at one interface at a time, but it can support multiple interfaces. Otherwise, let's cover the options. You've got, hey, let's dump the initialization vectors. You can set it up to work with a GPS server. You can do a -- write or a -w. These are effectively the same things. This allows you to dump to a file. You can record only the beacon information from access point to access point. You can update in a particular time, like, for example, every 3 seconds, flash to the screen a new update. You can show acknowledgments. This prints the acknowledgments and the retries and some basic statistics. I generally stay away from that, especially at first. You've got -h, which does not help but hides known stations. This is helpful because once you find the station that you want to target, you really want to filter out all of the other stations that you're not interested in. You've got a tac F here. This is time between channel hopping. You've got a -- Berlin. This is the time before removing the access point of the client from the screen when no more packets are received. In other words, if you don't hear from it in so long, okay, let's clear it out from what we're looking at. Tac R for read. This basically reads from a file. -x, active scanning simulation in milliseconds. Set the manufacturer. Set the output format, and I do typically use this because this is actually helpful for documentation. So the formats that are supported are packet capture, initialization vectors, comma separated value, GPS, Kismet, and net XML. Or ignore -1, removes the messages that says, fixed channel for etc. Otherwise, you have some basic filtering options and how you can sort this. If you want to sort via encryption or net mask or basic server set identifier, etc., etc. All right, so it's relatively easy to use once you understand some basics about wireless sniffing and pen testing, which we're building up to. Okay, so to basically set this up, I'm just going to run a capture for the initialization vectors, and I'm going to do this to my wireless interface. So it's just airodump-ng, capture the IVS, or whatever option you want, and then the interface in which you want to capture that on. So once I do that, then you get to see the different items and how they come in. Okay, so at first this may look a little goofy, in terms of it refreshing and things like that, but it's not that bad. It really isn't. All right, so a couple things here. You have your basic service set identifiers. You're always interested in these because these are basically the MAC addresses of the access points. And remember that these are 6-byte fields, so this is your manufacturer. This is unique per person. So I'm looking for like 001F90. That tells me common manufacturers that are in play. This is helpful when you're looking at a group of access points. Next, I've got the power, which is the signal level. I've got the actual beacons. This is the number of announcements in the packet sent by each access point. I've got data, or # data. This is the number of captured packets, for example, unique initialization vector count and things like that. So you can see I've got a couple higher initialization vector players on the network. I've got # s. This is the number of data packets per second measured over the last 10 seconds. So in this case, not a lot of traffic on the network. I've got the channel which it's on, so most everybody here around me is going to be in channel 1. I've got MB. This is the maximum speed supported by the access point. So in this case, I'm basically at 54. The dot after 54 above indicates that there's a short preamble that is actually supported. I wouldn't worry about that for now, but it does mean something later when you get into the advanced stuff. You've got ENC for the encryption algorithm that it thinks that it can enumerate. So here's an open access point, here's WEP, here's WPA2, etc., etc., etc. The actual cipher, these ciphers could include anything from like CCMP, RAP, TKIP, WEP, WEP40, WEP104, which keep in mind that that subtracts the 24-bit initialization vector, because normally we would call those 64 and 128. But if you subtract the 24-bit initialization vector, it's 40 and 104 accordingly. And or TKIP is an option here for the cipher type. The authentication protocol that is supported. Okay, so in this case, you can see all of them are set up as pre-shared keys. That's huge all in itself, because what I can enumerate here is if they're basically relaying the authentication to some sort of radius TACAX client, or is this basically just a pre-shared key? Since these are all pre-shared keys, then I got a couple of choices about how to attack this type of network. One, go find the pre-shared key. Is it written on the conference rooms, the boards, office, cubicles, trash cans, on the actual bottom of the devices, if I can get access to the actual devices and things like that. And then, of course, the extended service set identifier. This is the so-called SSID, for lack of better words. Then you've also got the station in itself down here. So the station is the MAC address of each associated station, or stations are basically connected to the actual access point. I've also got lost. This is the number of data packets lost over the last 10 seconds. The number of packets, the number of frames, the number of probes, all which can be useful depending on the TAC that you're actually using. Okay, so if you notice here, if I scroll to the top, okay, you've got channel 6, elapsed 1 minute, got little status updates at the top here. And then basically it goes into the core and what you're finding, which looks very, very similar to what you would see if you were to go to your, wireless network adapter cards. And then basically a summary of the basic service set identifier, the station, the power rate, loss, frames, and the probes. So, and when you're done, you can just go ahead and select Control-C, and that'll stop it. And again, just to capture initialization vectors, that was extremely, extremely easy to do. It was basically airodump-ng --IVS -WLAN0. But let's say that I want something different. Let's say I'm not interested in the initialization vectors and I want the actual beacons. Okay, you just change IVS's to beacons here, and it'll go through and you'll see all the beaconing access points. And basically it'll simply count the number of beacons here, right here. So in this case, I've got the NSA van outside. It looks like it's sending a lot of beacons out at the moment. So that's it. Very simple program to use. Hope you enjoyed the video, and I'll see you in the next wireless pen testing lab. Thank you for watching. My name is Leo Drager, and don't forget to check us out if you haven't already by now on Facebook, LinkedIn, YouTube, and Twitter.